All right, this is from chapter 4, mean value theorem problem using a trig function. Here's a mean value theorem for derivatives. If y equals f of x is continuous at every point of the closed interval a to b and differentiable at every point on its interior a, b. So if it's continuous, that means it can't have any jumps, no holes, no vertical asymptotes, no breaks in the graph. Differentiable means if it's differentiable, it can't have any vertical tangents, can't have any corners, can't have any cusps, can't have any discontinuities. It's got to be a nice smooth curve, something like this. If those two conditions are met, then there's at least one point C in the open interval AB at which f prime of C equals f of B minus f of A over B minus A. F prime of C represents the slope of the tangent line at C. Slope of tangent at x equals C. Anyone know what the right side represents? If we're doing f of B minus f of A, that's that rise. B minus A, that would give you that line. So it would give you the slope of the secant line. Slope of the secant line between points A and B. What we're saying is there's at least one point between A and B where the slope of the tangent line equals the slope of the secant line. So the two lines would be parallel. And there's at least one C value where that happens. What you're going to be asked to do is be able to find that value of C. Real life application might be something like this. Somebody went through a toll booth on the highway, went through another toll booth, averaged 90 miles per hour during that time. We would know if they averaged 90 miles an hour during that interval that they had to have gone 90 miles an hour at least once during their trip. Okay? All right, here's the question we're going to do today. If f of x equals cosine of x over 3, then there exists a number c in the interval where c is between 2 pi and 6 pi that satisfies the conclusion of the mean value theorem. Cosine graph is a nice smooth curve. Okay? It's differentiable, continuous everywhere. Find all values of x on this interval. So we're going to use this formula. Now on the quiz, that was on there for you. But on the test, on the chapter 4 test, you're going to have to know that formula. So make sure you have that memorized. So what you do is you do the derivative of your function. So f prime of x. What's the derivative of cosine? Negative sign, yep. And you copy down what's in the parentheses. Then by the chain rule, you have to multiply by the derivative of what's in the parentheses. Now realize that x over 3 is the same as 1/3 x. So what's the derivative of 1/3 x? 1/3. So you got to multiply by 1/3. So you're going to have a negative 1/3 out front. Again, that's the chain rule. The derivative of cosine is negative sine. Copy down your inside function of x over 3. Multiply by the derivative of x over 3, which is 1/3. Now, f prime of c. That means you just put a c into your derivative. So you're going to have negative 1/3 sine of c over 3 equals f of b. Which numbers up here are your a and your b?
2 pi and 6 pi.
A is 2 pi, b is 6 pi. So you can have f of 6 pi, that's your f of b, minus f of 2 pi, that's your f of a, over 6 pi minus 2 pi. So you have negative 1/3 times the sine c over 3 equals f of 6 pi. That means you're going to plug 6 pi into your original equation. So notice this. Use the derivative on the left side. Use the original function on the right side. So f of 6 pi means plug 6 pi into the original function. So cosine of 6 pi divided by 3. What's 6 pi divided by 3?
2 pi.
2 pi. So you're going to end up with cosine of 2 pi. F of 2 pi. Put a 2 pi in there. So it's going to be cosine of 2 pi over 3. Six pi minus 2 pi is 4 pi. Let's use unit circle to calculate some of this stuff. Here's 2 pi right here. Cosine's your distance left or right. So what would be the cosine of 2 pi? 1. 1, good. Yep. So negative 1/3 times c over 3 equals 1 minus, this is like 1/6, 2/6, 3/6, 4/6, or 2/3 pi. You're going a short distance left, so that's your cosine. What would the cosine be? You're going left, and it's the short distance on the unit circle. Left though, left.
Oh, negative 1/2.
Negative 1/2. Alright, let's bring this up so we can see a little better. Okay. Let's simplify this a little bit. Negative 1/3 sine of c over 3 equals 1 minus negative 1/2, that's going to be negative 3/2 divided by 4 pi. But instead of dividing by 4 pi, you can multiply by what? Instead of dividing by a number, you multiply by its reciprocal. So let's multiply by 1 over 4 pi. Instead of dividing by 4 pi. So it's going to give you negative 1/3 sine c over 3 equals negative 3 over 8 pi. What would be the next step? Times by negative 3 to get rid of this negative 1/3. We're going to work outside in. We're trying to solve for c, but we're going to work outside in to get to c. Multiply by negative 3, so those would cancel. Times by negative 3, that would give you 9 over 8 pi. So sine of c thirds equals 9 over 8 pi. So what do I do next? Take the, what'd you say that again?
The inverse sign.
Inverse sine of sine cancels that out. That gives you c over 3. Take the inverse sine of 9 over 8 pi. Just need an inverse symbol here. So the inverse sine, that cancels that out. This is a symbol for inverse sine on the right side. Now I just multiply by 3 on both sides. C comes out to 3 times the inverse sine, 9 over 8 pi. Type that in. Right there, side. Type that in the calculator. So 3 times second sine of 9 divided by, you're going to put the 8 pi in parentheses, otherwise it won't know that the 8 and the pi are both in the denominator. And we get c equals 1.099 if we round it. Now, here's a problem. Anybody see a problem? Here's my interval, 2 pi to 6 pi. 2 pi is 2 times 3.14, so that's about 6.28. 6 pi, that's about between 12 and 13. Does 1.099 follow this interval? No. No. So that's not an answer that we can use. Okay? So a better way to solve problems where you're trying to solve a trig function, and the other thing is there could be more than one answer. There might be 2 or 3 answers. A better way to solve these if you have a graphing calculator is go back up here and graph both sides of the equation. So that's what I'm going to show next, is to graph both sides and write down all the values of c that you come up with. So we're going to push y equals. And type in sine of, for c we have to use x, divided by 3. And for y2 it's going to be 9 divided by quantity 8 pi. If you don't put those parentheses, it won't know you want the pi in the denominator. Let's set our window going from x min of 2 pi, x max of 6 pi, and let's x scale of pi divided by 2. I don't know, well, I'm not going to worry about the y values. I'm just going to hit zoom 0. That'll fit my y values for me. Zoom 0. How many answers do you think this shows? Just one. The intersection points are your answers. So Had I gone a little further, I might have got another intersection point. But there's only one that's on the interval. So I've hit second trace, number 5. But the mean value theorem guarantees there's at least one value of C on the interval. So I knew I had to find at least one answer. But there could be 2 or 3. If there were 2 or 3 intersection points, I'd write them all down. In this case, our only answer is C equals 8.326. It's right there. Here's where we're getting it from. Any questions?
So if we had something like that on the test, the best thing to do would be get where you got the sign right there, and then graph it on your calculator and find where they intersect.
Right. Graph both sides, because that's going to guarantee you that you're going to get all the answers that you need.
And don't worry about the last 3 steps you did, because it did.
Right. I wouldn't really worry about this. This is another way to do it that you might have learned in pre-calc 1, but I'm just showing you that that method, you have to be careful because